Right, let's get going. Welcome to Gavin Lon Digital. My name is Lon. We are going to look at C# loops in this tutorial. But firstly, please subscribe to support the channel. It will be greatly appreciated. If you are already subscribed, please smash the bell icon so as not to miss out on future content, which will be coming soon. So let's create an example of a do-while loop. Okay, the way I'll structure the code for this tutorial is that I'll create separate methods for each loop example. And when we need to test a particular example, we can simply call the appropriate method from the main method. So let's create our first method. We must use the static keyword because this method will be called from the static main method. The method will not return a value, so we must use the void keyword to indicate this. We're going to implement code that executes a do-while loop in this method, so let's name our method loop10 do-while loop. Code that increments an integer variable will be added within the do-while loop. With each increment of the variable and iteration of the loop, the value of the variable will be written to the console screen. So let's define an integer variable and initialize its value to 0. We'll also create an integer constant to store a value denoting the maximum amount of iterations we want our loop to execute. Let's write the structure of the do-while loop. So you can see that the while statement contains the Boolean expression. This expression is evaluated each time an iteration of the loop is executed, which essentially means that the do loop should continue executing iterations when the do-while expression is true. So once x is greater than or equal to 10, and therefore obviously not less than 10, no further iterations for this do-while loop will be executed. Right, let's call this method from within the main method and run the code. And the result is as expected. 10 values are written to the console screen. Note that the loop first iterates code when x is equal to 0. Because 0 is considered a value, 10 numbers are written to the console screen from 0 to 9. Note that for the do-while loop, the termination condition is evaluated at the end of the loop, which means that at least one iteration of the loop will always be executed. This is unlike the while loop, which we'll discuss soon, where the termination condition is evaluated before code within the loop can be executed. So if the expression for the while loop returns false when it is first encountered, the code within the while loop will not be executed at all. We'll demonstrate a while loop shortly, but I want to show how the break jump statement can be applied within our example. To save time, I recommend a copy and paste of the code from the first example, then rename the newly created method loop10 do-while loop break at 4. When the value of x is equal to 4, we want the loop to be exited. So to do this, we apply an if statement testing the value of x with each iteration of code within the do-while loop. Within the if statement, we can apply the break keyword, which will terminate the loop. Okay, to make what is happening clear, when we test the code, let's add code that will output text before the loop executes and after the loop executes. And you can see the values 0, 1, 2, and 3 are written to the console screen. After 4 iterations, the loop was terminated. When the break keyword is executed, the code, if indeed there is code, directly after the loop will be executed. Let's create an example of a while loop. So let's create a method named loop10 while loop. In this example, we'll implement the same functionality as our first example, but instead of implementing the code using a do-while loop, we'll use a while loop. So we'll use the static keyword and the void keyword when creating our new method. There are no parameters for this method, so the brackets following the method name are empty. So let's define our x variable and initialize it to 0. Let's create our integer constant denoting a constraint on the amount of iterations that can be executed for our while loop. Let's implement the while loop structure. And you can see that the termination condition is found at the top of the loop structure. So because of this, it is possible that the code within the loop will never execute. As discussed, this is unlike the do-while loop, where the code within the loop is always executed at least once. This is because with the do-while loop, the termination condition is found at the bottom of the loop code structure. So let's write the code within the loop that will write the value of x to the console screen with each iteration of the loop. Let's make sure that we are calling the appropriate method from our main method, and let's test the code. And the result is as expected. Before we move on to the next example, let's look at a pictorial view of the logic for a do-while loop and a while loop. And you can clearly see from the two flow diagrams the difference between the two loop code implementations. Very simply, the do-while loop executes one or more iterations, and the while loop executes 0 or more iterations. So let's demonstrate the continue jump statement by adding the continue statement within our while loop. Let's duplicate the method we have just written and change the name of the new method to loop10 while loop continue at 4. Let's write an if statement within the while loop. The condition of this if statement is that the code within the if statement must run when the value of x is equal to 4. And the code within the if statement will simply contain the continue jump statement. Let's make sure we are calling this method from our main method, and let's test the code. Okay, so the code seems to have hung suspiciously at the point where x is equal to 3, which means the loop has executed 4 times. What could be the problem? Okay, so what is happening is that the continue functionality has caused an infinite loop. Let's take a closer look at what is happening by putting a break in the code and stepping through the code. So you can see that the continue jump statement is continually being hit, therefore jumping to the while termination condition each time it is hit. So the termination condition is being run once the continue statement is executed, and because the code below the continue jump statement that increments the x value is not being run, x is always equal to 4. Code to increment the x value is not being hit. So when the expression in the termination condition tests the value of x against the value in the max value constant, which is set to a value of 10, this test condition is always true, so the loop will execute infinitely. The continue code causes the code below the continue statement to never execute, which means the value of x will always be less than max count. So we are missing a line of code to ensure that an infinite loop is avoided. We need to increment the x value within the if statement before the continue jump statement is executed. Right, now let's test the code. And the result is as expected. So now you can see by the result that when x is equal to 4, the code that writes the value of x to the screen is skipped. But because the value of x is now incremented before the continue jump statement, we are avoiding the creation of an infinite loop, where the expression evaluating whether to continue running the loop is always true. So we have looked at the do-while loop and while loops in C#. Another common way for creating loops in code is using a for loop. So let's show how the for loop works through a code example. Let's create a static method and name it loop10 for loop. This time we'll declare only the integer constant at the top and not the x integer counter variable. Let's create the structure of the for loop. So at the top of the for loop, we need to create 3 statements separated by colons. In the first statement, we declare the x integer variable and initialize it. In this case, we'll initialize its value to 0. We could have defined our variable in the same way as x was defined in the other examples, i.e. at the top of the method with the max count constant. The reason we are defining the x variable within the for loop structure is because the code of the x variable only needs to be local to the for loop. This means the x variable cannot be accessed outside the for loop. So the next statement to the right of the first statement in our for loop structure is an expression, which is akin to our while loop termination expression. So while this expression is true, the loop will not be terminated. Conversely, when this expression is false, the loop is terminated. The third statement in the for loop structure is an incrementation operation of the x variable. Okay, so let's write the code that we wish to repeat for each of the iterations of the for loop. This code will write the x value to the console screen. Let's run the code, and the result is as expected. Right, let's look at nested for loops. So a nested loop is a loop that is executed within another loop. Just as you are able to use any of the jump statements within any of the loops discussed in this tutorial, you can also create nested loops for any of the loops discussed in this tutorial. But let's look at nested loops through an example using for loops. Let's first define the number of iterations that we wish the code within the loops to repeat. We can do this with two constants. The first constant is named max parent loop count and will be used in the expression of our parent for loop. Let's set its value to 10. Let's then define a second constant. We'll name it max child loop count, also as an integer, and we'll set its value to 5. Okay, let's create the code for the for loop structure for the parent loop. In the first statement, we'll define a variable x with a scope local to the parent loop. This variable is our counter variable. The next statement is a Boolean expression that gets first evaluated when the loop is first encountered in code, and then each time an iteration of the loop completes. So this expression reads as if x is less than the value stored in the max parent loop count constant, perform an iteration of the loop. The third statement performs an incrementation operation of the x variable. So with each iteration, the x variable is incremented by a value of 1. So the code within the loop will output the value of x. Notice that the console.write method is applied here instead of the console.writeLine method. This is because we want the subsequent output to be written on the same line as the x value. So we'll make sure the x value is followed by a space character and a colon for better readability. Let's implement the nested or child loop. The integer y is defined in the first statement of the loop, which makes the y variable's scope local only to this child loop. Effectively, this reads as perform another iteration of the loop if y is less than the value stored in the max child loop constant. And we'll use the console.write method once again because we want all values outputted within the loop to be written on the same line. So we write the y value followed by a space for better readability. And when the child loop is exited, we want the subsequent values of the following loop to be written to the next line. In order to achieve this, we simply write the console.writeLine method with empty brackets. And I've already inserted the nested for loop method in the main method, so we are now ready to test the code. So let's run the code. Great, the result is as expected. As you can see, for each iteration of the parent loop, the value of x is written to the console screen, followed by the values of y, which represent each iteration of the child loop. The process of this code is that for each parent iteration, the child loop iterates until the child loop is terminated. The process I've just described repeats until the parent loop terminates. So we can also decrement the for loop counter. Let's copy and paste our nested for loop code. Let's change the newly created method name to nested for loop child loop decrement. To demonstrate decrementing the for loop counter, let's apply the appropriate code to the child loop. So first we need to initialize the y counter variable to the value stored in the max child loop count constant. So we can change the expression to be y is greater than -1, which reads like this. The Boolean expression returns true and therefore executes another iteration of the loop until the value of y is 0. Then in the third statement, we simply change the plus plus to minus minus, which means we are counting down the value of y with each iteration of the loop. The starting value of y will be the value stored in the max child loop count constant. Okay, so let's call the method from our main method, and let's run the code. You can see the code is counting backwards from the value of 5 to 0 for our y value, for each iteration of the child loop. So because we include 0 as a value, the loop has actually executed one more time than we want. We want the child loop to execute 5 times and not 6 times. So let's alter the code slightly. So when we initialize y, let's initialize its value to max child loop count -1. And you'll often see this in loop expressions where there is a -1 added to the right of the maximum iteration constraint for a loop. The reason is that 0 is often used as the first index of a collection, for example an array. This means the amount of elements in the array is 1 greater than the highest index for the array. So let's run the code. So now you can see the value of y decrements from 4 to 0, which is a total of 5 iterations, which is the result we want. So let's discuss foreach loops. The foreach loop allows the developer to implement a loop that doesn't require a termination condition or a counter, and I'll briefly explain how this is possible once we have looked at an example. So in this section of the tutorial, we'll use concepts with which you may or may not be familiar, namely interfaces, classes, methods, properties, and arrays. All of these concepts will be discussed in detail in upcoming tutorials, but for this tutorial, a very superficial understanding is sufficient. So in this example, we are going to use a foreach loop to loop through 4 car objects and write the maximum speeds of the cars that the car objects represent. So let's first create an interface. Let's call this interface iCar. In our interface, let's create a method signature for a method named getMaxSpeed. A method signature is a definition of a method. The method signature in the interface cannot contain any code implementation. An interface is used for design purposes and not for the implementation of code logic. Let's also create a property definition in our interface. This property will be called carLabel. This property is used for the purpose of identifying the car. Right, so now we want to create the code that will implement the iCar interface definition. So let's create a class named car and indicate that we wish to implement the iCar interface. We do this by following the car class name with a colon followed by the interface name, iCar. So you'll notice red squiggly lines appear under iCar in our code editor. The compiler is telling us that we have not implemented all the properties and methods of the iCar interface, so we have signaled to the C# compiler our intention to implement code for the iCar interface, but we have not yet fulfilled this obligation. If you implement an interface, you must implement code for each of the items, for example methods or properties, that have been defined in the appropriate interface. You can think of an interface as like a contract between the interface and the class that implements the interface, where all the items, for example methods, properties, events, etc., in the interface must be appropriately implemented in the class that implements the interface. Okay, there is a quick way of getting rid of the squiggly lines in Visual Studio. We can simply right-click on the squiggly lines and select the context menu item labeled Quick Fix, and then we can select the Implement Interface context menu item. This auto-generates code for us that creates default implementations for our interface, method, and property. Right, so I'm going to alter the code so that it is fit for purpose. Don't worry too much if you don't fully understand what I'm doing here. This will be discussed in more detail in upcoming tutorials. Now that we have created our class, I'm going to create the calling client code, firstly in the main method. So first let's create an array of car objects, and we'll name this array cars. Again, don't worry too much. If you don't fully understand the code here, arrays will be discussed in detail in the next tutorial. So for each of the car objects that we are instantiating with the new keyword, we are passing in firstly the maximum speed of the car, and the second parameter is a label for the car. And now we can see the magic of the foreach loop and how it is quite elegant in its simplicity. The code itself is also self-explanatory and human-readable. So the code reads like this: for each object of type iCar that exists in the cars array, execute an iteration of the loop. The loop terminates once all the items in the array have been traversed. So within our foreach loop, code is included to write a brief narrative to the screen. Okay, so to be consistent, let's copy the code that has just been written to its own method. and then call the method we have named foreach example from the main method. Right, let's test the code. And as you can see, the code traverses each object of type iCar in our cars array and appropriately outputs each car's label, followed by the appropriate car's maximum speed to the console screen. So let me show you why the foreach loop can be called without a termination expression and a loop counter. The reason is because the array abstract class from which all arrays in C# are derived implements an interface named IEnumerable. Behind the scenes, the IEnumerable interface makes it possible for a lot of detail regarding the functioning of the foreach loop to be abstracted. So if I type array in the code editor, select and then right-click it, then select the Go to Definition context menu item, you can see the abstract array class implements the IEnumerable interface. This enables a lot of the heavy lifting of the foreach code to be done behind the scenes. This will be explained in more detail in upcoming tutorials. Please see the description below for details of where you can download the code from GitHub. If you feel you've gained value from viewing this tutorial, please consider giving it a thumbs up. It will be greatly appreciated. And please subscribe. If you're already subscribed, please smash the bell icon to be notified of future content, which will be coming soon. Please feel free to engage with me via the comments section. Thank you.